Okay, welcome. Thanks for coming. And this is actually our very last webinar of the whole class. So hopefully you found these webinars useful. I think it makes a difference having a webinar versus not having a webinar for online classes. You don't have a webinar, you're just reading and that's it. This brings, gets everyone kind of be interactive and all that kind of stuff. So I like the webinars and usually people like them. So let me tell you the plan today. As always, I'll answer any questions you might have. And then after that, again, this is our last webinar, which means we're at the end and we're going to cover the very last topic for the course. And the last topic of the course is a hypothesis test called ANOVA. And it actually stands for Analysis of Variance. But the reason why it's called that is something that we're not even going to get into because the math is too hard. But the really what we're going to be looking at is a hypothesis test to decide if there's a difference between a whole bunch of means. So that's something we haven't done yet. We've talked about comparing two means and to see if there's a difference from one mean to a different mean. But you might have 7 means and 7 variables that are quantitative. And we may want to decide, hey, are they all the same or not? Maybe it's, something about day of the week. And is every day the same? Or maybe they're not all the same. And that's kind of what ANOVA is going to do. And this is for quantitative data. So this is something we have not yet done in our class, is looking to see if a group of means, more than just 2 means, are all the same or not. So that is pretty much the topic. Then we're going to look at the requirements for ANOVA. It turns out that there's a bunch of things you need to be true. And a lot of times those are hard. But because this is an elementary stats class, I'm just going to let you know what you need. And you got to take an advanced stats class to find out how to tell if you have what you need for some of the things. So I'll mention them a little bit, but I'm not going to get into any details on that. We also do I'll do an example of ANOVA. They all look pretty similar. So one example is pretty much good enough because if I do 2 examples, then you'll just see the same thing twice, basically, with a different background or something. And then I want to remind you a bunch of things, actually. One is project 2 is due on Sunday. I recommend strongly that you get that done. You think about trying to get it done by Saturday, and that way, if something goes wrong, you still have another day. Because doing it the last minute is always a bad idea because that's when things can go wrong for you. So it's a better idea to push it one day ahead and call that your deadline. And then if something goes wrong, you have the extra day. So that's just a note. And I'll talk about project 2. I'll answer any questions you have about it. And maybe I'll give you some suggestions too. So just a note in terms of our calendar, and I think it's worth it to look at the syllabus for the class. And that is, again, project 2 is due June 25th. We're at the end. So we're at the end. The very last day, basically, to submit anything is a week from tomorrow, 8 days from today. You're welcome to submit early, but you're not welcome to submit after a week from today. So there aren't that many things. There's a project to do. There's going to be a ANOVA, or I'll pop in here where it shows all the things. There's going to be a chapter 13 ANOVA assignment. You have a concluding discussion, and I will let you know that there is no reason not to get 100% on this discussion, because you don't have to do, it's kind of like the very first one of the quarter. The last one's very similar to the very first one. You don't have to do any statistics. You just have to chat about how the class went, basically. So it's an easy one, but the way to lose points is to not do it on time. That's really the only way to lose points, or to not do it at all. Of course, that's even worse. But so make sure you get that done on time, because it'll take 5 minutes, and that's it. Maybe 1 minute. depending on how fast you can type. So it's just to know that's an easy one. Project 2, I just talked about a little bit ago. There's a secret word webinar, secret word quiz that you are used to, and that'll be the last secret word quiz of the quarter. There's what we call a final exam, but I want to let you know that the final exam is worth the same amount of points as all the other exams. So it's not like, your whole grade depends on this final exam. It is 10% of the grade. So you don't want to like skip it or something. But what I've done is I've decided not to make any of the exams like special weight or something. Each one is weighed exactly the same as the others are weighed. So, but the date is very different because you're used to having to do it by Sundays. And that is different for the final exam because the idea is you finish by Wednesday, 8 days from today. And then that's the end of the course. And then I'll spend the next couple of days grading it and you'll see your grade. Okay, because the class closes and that way you have at least a couple of days to look at your grade after I've sent your grade, maybe one day. So there is that final exam. The final exam looks very similar to the other exams. It's going to be, as you've noticed, every exam covers a whole bunch of stuff from the prior stuff, and then kind of have more heavily weighted on the new stuff. Same thing with this exam. So it'll be a whole bunch of stuff from chapters 1 through 12, and then more heavily weighted on chapter 13. And there'll be some chapter 13 written problems that you have to do. And that's it. That's the whole course. So we are literally, the light is at the end of the tunnel on this one. There is no webinar next week because the class is over next week. So you don't need a webinar. But I'll still have office hours in case, I don't know, whatever. And I'll also let you know, don't even ask for extra credit. I don't give extra credit in this class. So don't say, hey, I need more points. Give me extra credit. I'm not giving extra credit. It's not how this class works. So the credit is based on the exams and assignments and projects that you've been doing throughout the quarter. And if you've done well, you do well. Okay, so that's it. There is no extra credit. Don't even suggest it because my answer. We don't do extra credit. Okay, so right now, whatever your grade is, it's not going to change that much. So hopefully you have a good grade. So that's kind of the schedule, and hopefully that'll work for everyone. And again, I'll be around pretty much every day except, on office hours every day except weekends. And then I do check my email a little on the weekends. I might be backpacking again this coming weekend. We'll see. Just like I backpacked last weekend. But I don't think anyone tried to get a hold of me anyway, so it was no big deal. But I do have like a day or two that I might be, Saturday and Sunday, I may or may not be even online at all because sometimes I'm off grid. But during the week, I'm definitely able to help out. Also, the tutors are available. Okay, and there's a lot of hours for them. So, make good use of them. So are there any questions about anything right now? Any questions? Again, you can ask it with your voice. You can put it in the chat box, and I'll be happy to answer. Any questions? Okay, if there's no questions, I do want to let you know that, just like always, anytime if you come up with a question that you hadn't thought about, you can still post it in the chat box. So just because I didn't say, are there any questions, you can still ask questions anytime. And I always have one eye in the chat box and I'll be happy to answer, or you can say them too. Okay, so let's go to ANOVA. And here's what ANOVA is. So ANOVA, again, is called, it stands for analysis of variance, but it's kind of tricky in that you're not even going to know that it analyzes variance because it really is going to test to see if several means are equal or not. It's not about variance. It turns out it uses variance, but we're not even going to understand that because that happens in the calculator, which I programmed for you. So That's analysis of variance, also called ANOVA. That way you have less typing. And it is where you have several different means and you want to find out if they're equal or not. Okay, and there could be a lot of them. So it could be, say, for example, is the average weight of adults the same in every state in the United States? Okay, might be true. My guess is it isn't true, but I don't know. I haven't taken statistics. But you could, find that out. You can't, there's no way you can find out the weight of every person in the United States because there's just too many people to weigh. By the time they're done getting weighed, then there'd be like new adults being born, being that coming of age, I guess. So, and then there's, we have a lot of states in the United States. So that would be an example where you can use ANOVA. Sometimes, you'll have not, dozens and dozens and dozens of groups. You might just have 3 different things that you want to compare. And again, we don't know how to do that using difference between 2 means test because that only is for 2 means. We have to do with 3, okay, or 4 or 5 or 100, whatever. So the null hypothesis is very similar for the null hypothesis. It's very similar to the null hypothesis when we had a difference between 2 means. Remember when you had a difference between 2 means, the null hypothesis was mu1 equals mu2, right? Sometimes you'd put letters below it like mu boys equal mu girls or something like that, or I don't know, mu online equals mu face-to-face, but you just have 2. With ANOVA, you could have many. So the way I write it is mu1 equals mu2 equals ... equals mu(n). So if there were 4 of them, you'd have mu1 equals mu2 equals mu3 equals mu4. Any questions on H naught? Any questions? Okay, again, it's always that the means are all the same and then you put it in symbols like that. Okay, H1 is a little different. And if you don't use my template, it could go bad for you. Because a lot of people think that, well, showing that H naught is not right. You have mu1 equals mu2 equals ... mu(n). You might think that H1 would be mu1 not equal to mu2, not equal to mu3, ... not equal to mu(n). But actually, that's not what H1 is. Because you could have, say, let's say it was weights, average weight in the different states in the United States, and maybe California and Oregon have the same average weight, but maybe Alabama is different. So you could have some of them equal and some not equal to each other, and then H naught would be false. So kind of the way you can say that in a sentence is at least 2 of the population means differ from each other. Okay. And again, you can put it into, context. If you're talking about weights, you would say at least 2 of the population mean weights are different in 2 of the states. Okay. Or there's at least 2 states where the population mean weight is different for those 2 states. Okay. It doesn't say which 2 states they are, but there could be 2 of them. Any questions on the idea of that? Any questions? Okay. Here's what you can't do. You can't just do a difference between 2 means for every pair of means. That doesn't work. And it turns out the reason is because if you did that and you did a hypothesis test for each of the pairs, which would be easy in a computer, the problem is that if you have, let's say, a 5% level of significance, well, if you had a 5% chance of a type 1 error and they were all the same, but you had to keep testing pairs for, like many, many, many different pairs, and there's going to be a very high chance of a type 1 error. So that's why we need this new test called ANOVA to be able to handle this, is to be able to handle the fact there are many, many different pairs that you should be testing. And just trust that ANOVA makes that work. Any questions at all on the idea of ANOVA? Any questions? And again, feel free. You don't have to feel wrong or whatever about asking questions. That's what it's all about. Okay, if not, let me let you know the requirements. Okay, and there's a bunch. Okay, these are kind of like, could be assumptions, but in the real world, you hope to not have to assume anything. You'd much rather just say that I know ANOVA is a good test to use. I've done everything I need to do, and I can use it. Okay, so here's one. Number one, and this one we've seen in pretty much everything just about everything we've done with hypothesis testing, and that is all sampling distributions are approximately normal. How do you get all sampling distributions to be approximately normal? What's the way you make sure that happens? So what's your thought? If you had to do a hypothesis test using ANOVA, how would you ensure that all sampling distributions are approximately normal? Yeah, and it's a sample greater than 30 or greater than or equal to 31 for every single group. So if you were like looking about, states in America, then you have to make sure that you weigh at least 31 Californians, at least 31 Nevadans, at least 31 Texans, at least 31 New Yorkers. It'd be a lot of work, by the way, but that's how you would do it. Any questions on that? Is make sure the sample sizes are large enough for every single group. Okay, so that's number one. And we've seen that when we had, like for project 2, you had to have over 30 for each of your samples, right? Okay, or for your sample, if you're asking 2 questions, then it would be 31 answers to each of the 2 questions. So same idea with large sample, with more groups. Okay, number 2 is something we haven't seen before. And that is the all population standard deviations are equal. Approximately equal is good enough, actually. And that is something that is more difficult to ensure. And what I will tell you is that, because remember, this is our last day of, last lecture class. What I will tell you is that if you want to find out how to make this work, you need to take another statistics class, because we're at the end and we're not going over it today. So that would be more of an advanced or, upper division or graduate level statistics class to find out if all standard deviations are equal for, multiple data sets. Okay. The next one, which is actually really hard in theory, really easy to understand, or pretty easy to understand. And that is you have simple random sampling, or at least no bias, for every single sample that you took. So for all of the groups that you're comparing, you didn't have bias. And we've pretty much talked about that since the very beginning of class. Okay, and there's lots of ways of reducing bias that is most of the time good enough, not perfect, but good enough. If you have a, stratified sampling with all the different types of things that you want to get rid of the bias, and that works pretty well. Cluster sampling with representative clusters could work. Simple random sampling doesn't work very well with people, especially if the population is very large. But sometimes it works with things that aren't people. Okay, like manufacturing, that kind of stuff. But we've talked about simple random sampling already, so I don't think I have to talk about it anymore because that's happened the whole course. The samples are independent of each other. Okay, so what you can't do is, let's say, survey 31 people, asking them 5 different questions and seeing if the answers to those 5 questions all have the same mean, because that wouldn't be independent. And what I will tell you, and again, that you're going to hear this a lot today, is that if you have dependent samples where you have many, then you need to take the next statistics class in a university, because it's an upper division or graduate level course, and you'll learn about that. And there's lots of different statistics tests that you can do to, do your statistics. Any questions so far? Okay, and then the final one is the samples were consistently taken. Okay. And this is important because let's say you were doing a study. Let's say I'm just going to use that weight in states, United States thing. Okay. And to be realistic, there's no way you're going to have time to go to every single state and weigh over 30 people in every state. That's not how things are done in the real world. Any guess on how things are done? If you were to do that, if you needed to do that particular experiment or that particular study, by seeing if the weights are the same in every place. Telecommunication, yeah, but most people lie about their weight. So you need to actually weigh them physically. I wouldn't say most people, but a lot of people lie about their weight. And that may not work so well. Especially if you're fat. Okay. So here's how it happens in the real world. You hire people. You hire people and maybe a person in every state and then have them do the work. Okay, because it's just too much traveling to go to all the states. So you hire people, and then in the end you telecommute. Okay, you basically telecommunicate, I guess. Is that then you ask them, hey, what'd you guys get? What'd y'all Indiana people get? But you hire them, and one of the things that's really important is that in this case, in every state, they made sure that they were consistent in how they did the weighing, for example. Okay, so for example, if one group weighed everybody right after Thanksgiving, that's probably a really bad idea. And another group weighed them just before because people gain weight at Thanksgiving. Does that make sense? Okay, so you make sure that every state is following the same technique of doing the sampling. Okay, any questions on that idea? Okay, in particular, my first job with the company, I think I gotta let you guys know, it was a while back, a long while back. This happened. So do you remember how old I was when I had my first job with a company when I had to help conduct studies? Yeah, it's 11 years old. And what would happen is we'd have a meeting. And the boss let us know all the things we need to do to make sure that we were all consistently conducting the study. Okay, so it's not that hard to do, but you just have to make sure that you pay attention and do it. Because if you don't, then you have people doing it in different ways, and that's a mess. And ANOVA doesn't work. Any questions on that idea? Okay, so ANOVA turns out to be really important. It's used a lot. Okay, it's used a lot. We're only spending today on it, and I guess the week, but the point is that just because you've had a lesson or chapter in ANOVA does not mean that you're experts in it. So it's one of those where it's, if you really want to be an expert in ANOVA, you need to take another class, because then you have to take something more advanced to learn about how to test all these different things. But we'll pretend we understand it. So let's look at an example. Okay. Oh, I should mention, I expect today to be a little shorter than usual because we just have ANOVA. That's all we have to talk about. And I can answer questions about the project too, I guess. But we probably will end a little earlier than we usually end because there's less to talk about. Because it's you'll see it's not the hardest chapter. Not the hardest chapter, but you do have a project due on Sunday. And I try to lighten up a little bit when you have the project due. Okay, so here's an example. Okay, suppose that a study was done. Okay, whenever I say suppose, that means I just made up a bunch of numbers. So, don't quote me on these, but you can imagine doing the study. Okay, to analyze the racial differences for the distance in miles that people live from the nearest public library. Okay. And the data from the study are shown below. For example, how many miles do y'all live from the nearest public library, from your nearest public library? Put that to chat box. Okay, so by the way, I live 3 miles from the nearest public library. I see 2, I see 12. So, people live different miles from the nearest public library. And the question is if you look at different races, is there a difference in how far on average white people live from the nearest public library compared to Black people, compared to Hispanic, compared to other races? Okay, that's the kind of test you would do, and the hope is that, we don't discriminate and have one race, not being able to get to a library, because that'd be bad. Libraries are good. Okay, hopefully you all agree that it's good to have a public library. So the idea is you can kind of suppose that a study was done and they asked some white people, some Black people, some Hispanic people, and some others. Okay. And they asked, how far do you live from the public library? You probably ask 2 questions, and what is your race? So that you know what category to put the person in. And these numbers just tell you how far. So for example, the first Hispanic person said, I live 9 miles from the nearest public library. The second Hispanic said 17, right? The first Black person said, I live 12 miles, and the next lived only 1 mile away. Okay. And that is an example of, a study that could be done. You can imagine a study like that. And that kind of stuff is done all the time, by the way. Okay. So what we should do first is say, what assumptions do we have to make to perform an ANOVA test for this? Okay, any questions on the first question? All right, so it helps to go back to our list of assumptions and see if we need to assume that, or do we already know it? Do we need to assume that all sampling distributions are approximately normal? So take a look. What do you think? Okay, well, let's look at it. Let's look at the sample sizes. The sample sizes for the whites were 6 whites. Okay, that's way under 31. So yes, you need to assume that the sampling distribution for white people, distance from the public library, is approximately normal. And Black people, we only had 4. That's even worse, by the way. Hispanic, we have 6, and other we had 4. Notice, by the way, you do not have to have the same sample size for each. Okay. You could still do ANOVA on this. We have to make that assumption, but let's say each of these had, 50, and the next one had 180, and the next one had 75, and the next one had 93. It's fine that they're different numbers. And in that case, for number 1, you wouldn't have to assume, because then you would have large sample sizes for every one of them. Okay. If, let's say, we had 35 whites, 4 Blacks, 50 Hispanics, and 20 others, then you would have to assume it for the Blacks and the others, but you wouldn't have to assume it for the whites and Hispanics. Okay, because whoever's over 30, you don't have to make the assumption. Any questions on the first one? So it's yes. Or let's say we need or must assume that all 4 distributions of distances from the nearest public library are approximately normally distributed. Any questions on saying that, yes, we do need to assume for number 1 because all 4 of them are at under 31. Okay, whereas if, again, 3 were under 31 and the other wasn't, then you'd only have to assume for those 3 and not the other. Okay, then let's go to the next one. All population standard deviations are equal. So I will let you know that for this class, you will always have to assume that. And as I mentioned a little while ago, that's because in this class, we don't cover any tests to decide if population standard deviations are equal or not. So if you go on to take a higher level statistics class, then sometimes number 2, you don't have to make that assumption. But we're not getting to that point, so we're just going to always have to assume it. Any questions on number 2? Okay, number 3 was there simple random sampling? And the idea, if you read the question, it just says a study was done. Okay, it doesn't talk about the study. It doesn't say how it was done. So if it doesn't say, then you have to assume it happened. That's what assume means. It means you don't know. So we're just going to say yes, even though we really don't know. If you do know, you don't have to assume, you just say it's true. Any questions on the simple random sampling piece? Okay, the next is the samples are independent. So I'm going to put that in, but I'm going to talk about it for a second. Okay. I'm going to say, but this is probably not an issue. How come? Any thoughts? I don't see y'all jumping in. Okay, the idea is, if you think about this study, you're just asking a bunch of people how far they are from the nearest public library. It's very unlikely that like these first four people are like paired up in any way. It's not like you're asking, multiracial families and only looking at those families. You're just asking people. So this one's probably not an assumption you would have to make, because I can't even imagine a study that people would do, in terms of reality, where it would be dependent for nearest public library and race. That makes sense, or did I confuse you? Okay. So dependent would happen if instead of, race, it was like, maybe siblings, when there's 4 people and siblings in a family and you ask all 4 kids, then that wouldn't be okay. That would be dependent, not independent, because they'd be paired up or grouped up, I guess. Any questions on that idea? Okay, and then the last one is the samples were consistently taken. That is assumption we know nothing, but this is also most likely true. Okay, because I don't think you would be like asking it differently if they were Black. You're just going to ask the survey question to all the people you talk to, and you're not going to hopefully you won't treat the races differently. Does that make sense? So if you treat Black people different than Hispanic people, then they wouldn't be independent. But if you just treat everyone the same, you ask them the same way, there's no problem. And they wouldn't be consistent. So as long as these are almost certainly be consistently taken. Any questions at all on the assumptions? Okay, so now show all the details of the ANOVA test and state your conclusions in the context of the study. Okay, so we got to start with H0. What is the null hypothesis? And again, we have whites, blacks, Hispanics, and other. What's the first letter I should use of H naught? W? Okay, W might be part of it. That's the second letter, actually, because the first letter I'm going to be using, as soon as I say it, you'll say, of course, is mu. Yeah, mu W. There we go. So the first letter is mu, and then sub W. And then equals, and then we're going to have mu. And then the second is for blacks. So how about B? And then equals, and then mu. And then H for Hispanic. And then equals, and then mu. And then how about O for other? Any questions at all on determining what H naught is? Easy enough? Okay. If there's only 4 of them, usually you just write them all out, just like I did. If it was, states in America, then you'd go for the ... thing because there's just too many and you don't want to sit there all day long typing every different state in America and just wasting your time. But 4 you can do. Okay. H1 is going to look very different from H naught because this is the one case where I suggest writing symbols for H naught and a sentence for H1. Turns out when I first taught this class, I used symbols for H1 and confused the hell out of everyone, so I don't do that anymore. Because there is a way of doing the at least one, but instead it's a lot easier to just put in a sentence. That is at least 2 of the population mean I guess at least 2, let's call it races, have different population mean distances from the nearest public library. Any questions on H1? So again, with ANOVA, it's easiest to do symbols for H naught and a sentence for H1 is what I want you to do for the exam, for example. Okay, name of the test. I hope you can all tell me the name of the test. Yeah, ANOVA. And ANOVA. And just note there's an abbreviation, so it's all caps. All right, what do you think level of significance? What would the appropriate level of significance be for this particular test? For this hypothesis test, what's the appropriate level of significance? Thoughts? Yeah, this would be 5%. Because it's sociology. right? Talking about racial groups and how far they're from the public library. It's a sociology thing. Nobody's going to die because, you made a mistake, or I mean, you got it wrong or had a type 1 or type 2 error. Okay. But it's something that you probably end up publishing, and 0.05 is a standard. And just let you know, this is not, what we're doing today is not something you're going to use in day-to-day life. Nobody goes to the supermarket and does an analysis of variance to decide what food they want to buy that day. Not what you do. ANOVA is pretty much used for publishing papers, journal articles. That's what ANOVA is all about. Okay. It's not something you're going to be using other than for journal articles. Okay. And you'll be reading journal articles maybe and seeing that they did ANOVA. But like I said, it's not a day-to-day kind of thing. So most of the time you use 0.05 unless some life depends on it or something. Okay, test statistic and p-value. How do you think we're going to get those? Yep, calculator. Okay, by the way, I promise you, you do not want to do this by hand. It is not fun at all. And here's the good news. What calculator number are we going to go to? To be obvious. Yeah, what's our calculator number? Yeah, 25. This is the end. This is the end. There is no more statistics after this ANOVA. That's it. So we're at the very end of the course. And that's ANOVA, number 25. And I click on that. And then it says, enter the data values separated by commas. Okay, you're used to doing that, hopefully. Then hit calculate, and the S statistic and p-value will be generated for you. Okay, and by the way, just to note, I only did data 1 through data 8. Okay, this calculator will not work if you wanted to do my first example idea, which is to find out if the weights are the same in all 50 states, in all states in the United States. Okay, what would you have to do if you wanted to find out the weights are the same in all states and you wanted to conduct an ANOVA test? And you didn't want to pay any money. Any thoughts? Because this won't work. This calculator will not work if you have more than 8 groups. I just made it. I made it for this class. I didn't make it for all research. Actually, you don't have to take advanced level stats. Well, I mean, you'll have to do a lot more typing. Yeah, it turns out that you can go to the spreadsheet that I created for the projects, but I actually created that for everything. And that is actually spreadsheet based, and you can have as many as you want, by the way, with that one. So if you needed to for, after this course is over and you needed to do some ANOVA calculation with more than 8 different groups, then you can just use that spreadsheet I created and that will work. Okay. And there's other spreadsheets out there, but I made sure that mine has everything we do in this class at least, and even a little bit more. Okay, so what I need to do is I need these numbers. I'm trying to remember if it allows me to copy and paste them, but we'll see. I did, good. I had to put commas between them. So I copied, I pasted, throw some commas in. So 15, 4, 11, 9, 3, 2. And then I do it for the next one. 12166. 12, comma 1, comma 6, comma 6. And then I need to do it for the next one. 9, 17, 5, 14, 1. 7, 1, there we go. And then we have 18, 11, 2, 8. Any questions on the entering in the data? Okay, and then I hit calculate. Okay, I will let you know that the test statistic is new. It's one that we haven't done in our class yet. And in our class, we've already done, if you remember, we've done the normal distribution. We've done the student's t distribution. We've done the chi-square distribution. We've done the uniform distribution. We've done binomial distribution. We've had a lot of different distributions, and this one uses a different one. This one uses what's called the F distribution. And again, you really got to be an advanced math major to truly understand what it's all about. So, or just trust it, use your calculator and smile. Sound good? Okay, so it's the F distribution, and the test statistic is this guy right here. Okay, so if you wanted 4 decimal places, then that would be 0.3339. So the test statistic is F is equal to 0.3339. Any questions on that so far? Okay, and then the p-value was 0.80099 or 0.801. Whoops. One more try. Copy. And then always use the rules of rounding, so we need to round up to 801. Any questions on that? I should kind of mention something since we're doing it. If I go back, I think I have it in here somewhere. This is the F distribution. So it turns out there's actually 2 degrees of freedom on this. And I'm not going to get into the details of that, but there's a numerator degree of freedom and a denominator degree of freedom. And if you have different degrees of freedom, it looks different. Okay. But you'll notice that it is a skewed right distribution. Okay, it's also, so skewed right, it's unimodal. Hopefully you know what those words mean, because that was earlier in this class, in this course. So it's skewed right, it's unimodal. It's also always positive. Okay, you don't need to go past the y-axis to the left of it because there are no negative values. And that's what it looks like. So then what we had, you know, if you had our F was 0.33 or something like that, then that's like over here. And you'll notice that the P is the area to the right of that, which is a really big area. And that's what we got. We have 0.8 for our p-value. Okay, and there is no left and right tail test on this one. When you have a ANOVA test, then it's just right-tailed. And that is just, are they all the same? Or are they not all the same? Okay. And you can never say they're all the same. You can only say there's insufficient evidence to show they're not all the same. Any questions at all on this so far? Okay, what's the conclusion? At least how does it start? Okay, P is greater than alpha, and because P is greater than alpha, what is that? What's the conclusion? Hope you know this because we've been doing this for like a month now. Yeah, we failed to reject H naught, so we can say there is statistically. What's the next word? Next word's so important.
Insignificant.
Yeah, insignificant. Okay, because our p-value is large, that's when you have statistically insignificant evidence to make a conclusion that, and now the good news is we have H1 in already written, and we're online, which means I can copy and paste and fix the grammar. Take that A and make it lowercase. So there is statistically insignificant evidence to make a conclusion that at least two of the races have different population mean distances from the nearest public library. Okay, does that mean that they're all the same? When we say that every race has the same average distance from the nearest public library? What do you think? Okay, the answer is no. You can never, ever, ever say that the null hypothesis is true and not be saying that. What you do is you find a very fancy way of saying we know nothing. That's what this is. There is statistically insignificant evidence to make a conclusion that at least two of the races have different population mean distances from the nearest public library. That's a fancy way of saying we really don't know. Okay, you can't say we do know. You can't do that when you have a large p-value. Any questions on that idea? I do want to make, I'm going to write this in a different way too, because I want you to be ready for your upper division courses, and not necessarily stats. It could be a psychology class or something where they do ANOVA and they write it differently. So I'm going to copy and paste. I'm going to change things. So there's still statistically insignificant evidence to make a conclusion that there's another way of writing it. And that is that race is a factor in the distance from the nearest public library. Okay, you'll often see it written that way. So if at least two are different, then race is a factor. If they're all the same, then race is not a factor. So being told what race somebody is, if all the means are the same, that's not going to help you at all in getting a decision of how far they are from the nearest public library. Okay, on the other hand, if they're not all the same, then if you're told what race they're in or they are, then you have a better guess on how far they are from the nearest public library. Any questions on this conclusion? Just a note, what if instead, so again, one big reason why we probably failed to reject, what do you think the most likely reason is? Yeah, we have sample size of 4. And hopefully, we're at the end of this course. That's never okay. Okay, I only did this because I just was lazy and didn't want to type and have you guys like sit there and suffer through my typing for, an hour long, typing however many really you need. Because Remember, 31 times 4 is 124. And that's a lot of numbers to type in. Okay, so go on and on and on. So just let you know that just because I did this example does not mean you should do this in the real world. In the real world, you have to make sure that you survey over 30 people in each group. Any questions on that? Okay, so, there's a really good chance that the reason why we had a high p-value was just a too small sample size. And that happens. What if we had done a big sample size and let's suppose instead we got a p-value of, let's say we got a p-value of 0.001. Then how would that change in terms of the conclusion if the p-value is 0.001? What would the only change be? It's a very small change, but really big in importance. Really small in typing. Yeah. So if you had a very small p-value, you just get rid of the IN. And you would say there's statistically significant evidence to make a conclusion that at least 2 of the races have different mean distances from the nearest public library. Do you see that? Okay, if you got a really low p-value, could you tell which races are different? Which is the bigger one? Which is the smaller one? Could you do that? Any thoughts? So if we had a really small p-value, could you say which one is the one, which pair are the different pair? Which one is the highest for distance to nearest public library? Thoughts? Not seeing it. So let me tell you, it's kind of a funny answer. The answer is you couldn't tell, but I could. You know why? Let's see, I'll jump again. Okay, the reason is you haven't taken an advanced level statistics class. I have. And there are more tests that you could do, something called Tukey analysis, and you could do an advanced statistics test to decide which ones are different. But in this class, we don't do that because we can only do so much in our class. We can't do every statistics test. So one of my jobs today is to say, hey, if you want to really learn more stats, you need to take more stats classes. So this isn't the end of statistics, even though it's the end of our course, if that makes sense. So it's really important to note that there's definitely more statistics to learn than what we have done. And it's not because, I'm lazy and I didn't want to show it to you. It's because we can only do so much in a 1/4 course. Okay. And I also do, I try and be very consistent with what everyone else in the state does. And pretty much everyone in California teaches the same topics. Okay. And I go to conferences to make sure of it. But that doesn't mean there aren't more topics. So are there any questions at all about ANOVA? Any questions? Okay, so what I'm going to do is I'm going to give you the last secret word of this class. And although it's a little different, it's 2 words. The secret word is thank you. Especially you that came and come. I want to thank you for coming. If you don't come, then no one would be here, and then we wouldn't. Then, everyone would be screwed because there'd be no webinar. So thank you for coming. And for those who are watching on YouTube, at least thank you for watching on YouTube. Okay, it's better than not watching at all. And the secret word is thank you. And thank you for, having a good attitude in this class. Haven't had any complete brats, which is good. Everyone seems to be nice in this class, which is a good thing. So thank you is a secret word. Okay, so secret words in this case because it's 2 words. Thank you. All right. As I mentioned, it's 1 o'clock, but I want to remind you again, we have project 2 to do. And that is due this week. Okay, I guess officially it's due on Sunday, which is officially next week, but the hope is you get it done this week. And I just want to mention, again, timelines. If you haven't already done it, and I know those are here have, send me your draft. So that's really important. It has to be sent by 8 a.m. this Thursday, better as before. And, I will get back to you on that. I also want to let you know that if you have questions this weekend, there's a chance I will not be there to answer. You don't know why? Not because I'm don't like you or something. Okay. And the hint is, I mentioned it, is that I wasn't there to answer last weekend either. At least for a couple of days. Last weekend? It was a 3-day weekend. Yeah. I'm thinking about backpacking. And when I backpack, there's no internet. So I don't answer any questions. If you find me, I'd be really amazed. Because I don't even know where I'm going yet. Somewhere out in the middle of the forest. Probably Tahoe area. Good luck finding me. So if I'm not available, if I don't get back to you on Saturday, okay, then, so there could be more than 24-hour time. I'll be back definitely by Sunday evening, though, just let you know. So there might be a day and a half or so I might be offline, and that would be over the weekend. So we all have lives, and that's what I like to do. Are you coming to Tahoe for real? Great. Well, if you can find me backpacking, good luck. That'd be cool. But you better be in really good shape because I hike far. Just let you know that. So in terms of my schedule, there may be times, I don't know if Kyle's around on the weekend. Are you around on the weekend? No. Okay. So you're not. I'm not sure if any tutors are. So don't wait until, Saturday or Sunday to think that you're going to get your questions answered on the last minute, because there's a chance that I may not answer. Okay. So, really, focus on getting all your questions answered by Friday. Because that's the time. So that's a note. In terms of the project, again, you can go back and look at the prior YouTube videos where I did the prior webinars where I talked about the project. Don't forget to address your client. That's the audience, and have your client. And then for every single detail, basically, talk about how the client is going to make a decision. Okay, so when you write down what your p-value is, what decisions might your client make based on the p-value? When you write down what your issues of the type 1 error are, talk about what the client might do. Issues of the type 2 error, what the client might do. When you look at deciding on what level of confidence, what confidence level you're going to be doing, well, that depends on what works for your client. After looking at the 3 different confidence intervals that we've done, the 90%, 95%, 99%, which works best, which is going to give your client the best information so that the client can use that information and make decisions that are going to help the client or the people the client wants to help. So don't forget that the entire project is really based on that. Okay, hopefully that makes sense. So those are the main things that you should be, making sure of. And again, most of the project, the vast majority of your writing should be on the hypothesis test and the confidence interval. Okay, that's what it's all about. How do you choose between p-value two-tailed, right-tailed, or left-tailed? Well, what's your hypothesis? So what's your H naught? What's your H1, I mean? So it depends on what your H1 is. So if you can type out what your H1 is, then I can talk about whether it's two-tailed, right-tailed, or left-tailed. You popped an image. I'm not seeing it. Just a minute. If I click on it, maybe I'll see it. It's not opening. That's going to take a while to open.
It's right-tailed.
It's right-tailed? See, I'm opening your image just a minute. Okay. So, yeah. So if you have H sub weekdays is greater than H sub weekend, that's the same thing as H sub weekdays minus H sub weekend is greater than 0. You see, if you subtract H sub mu sub weekend from both sides, you'll get mu sub weekdays minus mu sub weekend is greater than 0. So now, and this is important to understand, let me, I need to annotate. We have a normal curve because hopefully your sample sizes are large enough. And here's 0 right here.
Of course.
So if we're greater than 0, greater than 0 is the right-hand side of this graph. Do you see that? And since greater than 0 is the right-hand side of the graph, it's right-tailed. So that's what that's coming from. So it comes right from the picture. So hopefully that helps. That makes it right-tailed. Okay, whereas if you had that the means were, different between weekends and weekdays, then it would be two-tailed because then it'd be both sides. Whereas if you said the mean for the weekdays was less than the mean for the weekend, then it would be left-tailed because then it would be the left side of the graph. Yeah, so it's all in the picture. Okay, other questions? Good question, though. Important one. Okay, so two-tailed would be if your hypothesis was that there was a difference between weekdays and weekend. Because 0 is when they're the same, right? Being different means that you're either on the left side or the right side, and that's the two tails. So if your hypothesis had been that they were different from each other, that could be left or right because both tails are the different sides. Does that help? Good, good, good. And again, you never know what your exam question will be, so you should be ready because your exam has to be done by Wednesday of next week. So you have 9 days from now. You can do it earlier if you want. But one of the reasons why I don't have a webinar next week is that if you've already taken your exam, then there's nothing left in the class. There's nothing left in the class. Why have a webinar, right? There's nothing to talk about. So that's why this is our last webinar of the whole quarter. Okay, but that doesn't mean I won't be around to help. So I'm around to help, and so is Kyle. Okay. So we can definitely help you out. But after Wednesday, after next Wednesday, the class is over. Because I've already submitted your grades and then it's over. Any other questions? Okay, if there's no questions, let me stop the recording and thank you all for watching this and for coming for the whole quarter.